Mas Adit.
Ya, selamat malam rekan-rekan DevOps Indonesia. Kita jumpa lagi di DevOps Indonesia Online Meetup yang ke-50 ya, kali ini di bulan Desember untuk penutupan tahun. Kita kali ini mengangkat topik mengenai securing your applications. Oke. Jadi untuk topik kali ini untuk sesi pertama yaitu nanti akan mungkin terlebih dahulu Pak Didiet ya. Halo Pak Didiet.
Ya, halo.
Ya, Pak Didiet A Pambudiono akan membawakan topiknya mengenai secure your application with Google Cloud Apparmor ya. Jadi kita revisi untuk topiknya. Jadi Google Cloud Apparmor bukan Apparmor. Oke. Jadi nanti dari rundown-nya dari jam 7 sampai jam 7:10 itu opening dan announcement seperti biasa, kita introduction terlebih dahulu. Kemudian jam 7:11 sampai jam 8 nanti akan dibawakan terlebih dahulu ya untuk topik Pak Didiet ya, yaitu secure your application with Google Cloud Apparmor nanti oleh Bapak Didiet A Pambudiono, including Q&A. Jadi nanti mungkin pada saat sesinya berjalan, mungkin bila ada teman-teman ingin menanyakan sesuatu mengenai topiknya, nanti bisa langsung dituliskan di chat box. Gitu. Nanti lalu kemudian kita sambung ke sesi kedua, yaitu securing APIs when WAF is not enough, that will be brought by Mr. Itsik Mantin, including Q&A. Nah, jadi di sini nanti delivery-nya in English. Jadi nanti rekan-rekan misalkan ada pertanyaan, silakan nanti ditanyakan dengan menggunakan bahasa Inggris, dituliskan di chat box ya. Kemudian di sesi akhir, seperti biasa kita di 8:51 sampai jam 9 ada foto session. Nanti kita minta rekan-rekan sekalian untuk menyalakan videonya. Kemudian kita foto bersama, lalu nanti ada feedback dan closing. Oke, sekilas mengenai rules kita seperti biasa. Jadi untuk event ini kita live stream, nanti akan ditayangkan di YouTube channel DevOps Indonesia. Bila ada pertanyaan nanti bisa menggunakan fitur raise hand, atau nanti mungkin kalau misalkan ada pertanyaan seputar topik langsung dituliskan saja ya untuk di chat box-nya. Nanti QA session, pada saat QA session nanti kita akan bacakan. Oke, perkenalan singkat mengenai DevOps Indonesia, established dari Oktober 2017. Member meetup kita sekarang di meetup.com sudah lebih dari 3.300. Di Telegram sudah lebih dari 4.500 ya. Telegram grupnya di @id_devops. Nah, kebetulan misalkan kalau ada rekan-rekan yang belum bergabung, silakan bergabung langsung di Telegram grup kita. Kemudian website kita di devopsindonesia.com yang nanti akan redirect ke Meetup DevOps Indonesia. Oke, seputar infografis perjalanan Meetup kita, ya saya bacakan singkat saja untuk yang dari tahun ini ya, pertengahan tahun dari Juni, yaitu API Security Webinar. Kemudian di bulan Juli, Bapak Made Mulia. Kemudian di bulan Agustus, kita kedatangan tamu juga dari AWS dan PayFast. Kemudian di bulan September, yaitu kita kedatangan tamu dari Shopee dan juga DevOps Indonesia ya. Kemudian Trend Mikro di bulan Oktober, dan di bulan November kemarin kita kedatangan dari AWS lagi dan juga Codex. Kemudian di bulan Desember ini, kali ini nanti kita kedatangan tamu dari DevOps Indonesia dan juga Envision ya. DevOps Indonesia oleh Pak Didiet dan Envision Itsik Mantin. Oke, kurang lebih seperti itu. Nanti bisa stay connected with us juga dari Telegram grupnya, bisa di linknya di sini menggunakan ini, lalu juga untuk LinkedIn, Instagram, Facebook, Twitter, YouTube channel, dan juga Meetup. Bisa juga scan barcode-nya di sini. Oke, kurang lebih seperti itu. Jadi mungkin kita akan lanjut ke sesi pertama ya, yang dibawakan oleh Bapak Didiet mengenai Google Cloud Apparmor. Ya, silakan Pak Didiet. Saya serahkan ke tempatnya.
Ya, Mas Isnu, kayaknya di invitation udah ada Mr. Itsik. Mungkin
Oh,
kita
sudah
bisa,
ada Itsik ya?
iya,
Oke. Sebentar.
bisa kita schedule ke awal lagi gimana?
Oke. Hi Itsik.
Hi guys.
Okay,
Hi,
we're almost switching the schedule because you come late to this meetup.
No, I joined a couple of minutes ago.
Okay. For the next session, we already introduced the DevOps Indonesia for the opening. So
Yeah, I saw that.
Yeah, so we can go to your session directly for the first presentation.
Okay, thank you very much. Let me share my screen. Okay, do you see my screen now?
Yes, clearly. Thank you.
Okay, awesome. Thank you for inviting me. This is a great honor for me to speak at DevOps in Indonesia. First time I speak in Indonesia. I hope the next time it will not be a virtual one, but to come physically to this beautiful country. I will talk about securing APIs when your WAF is not enough. A couple of words about myself. I'm Itsik Mantin. I'm a VP Application Security Evangelist at iMvision. I'm working on cybersecurity and algorithms in the last 20 years and more. I worked in different domains, different companies. Recently, I joined the iMvision, a company that specializes in providing API security solutions to organizations of different sizes. Okay, I will start about with talk a little bit about APIs. So, what is API? I think that the main difference between API and web interface, as we know it, is that well, they have a lot in common. Both of them are based on HTTP. However, the web applications are accessed by humans or specifically by browsers. On the other hand, when it comes to API, they are consumed by machines. These machines can be mobile applications. They can be sometimes web services accessed by third parties or business partners. They can also be, in some cases, the browser generates request, the AJAX request to the website, and then again, this is a sort of API. And then instead of getting back HTML, what we get back is a data structure that can be either JSON or XML or structured any other structured data type. The APIs provide access to company assets and services. This access can be to many types of clients, can be mobile devices, can be websites that of business partners that can access and collect and get and fetch the data that they need. As I said, B2B partners and others. In the last couple of years, we're seeing tremendous growth in the usage of APIs. And this is just some statistics that we collected here at iMvision. That the number of APIs that are being deployed, that are being used, being exposed by companies, companies of size larger than 100 employees is at least 50. It's a double digits and at least 50 for 63% of the organizations we asked. Now, when it comes to management and control and securing, 5, 6 APIs, this is not a problem. Can be done manually. However, when there are more than 50 APIs that are dynamically changing versions, going up, going down, being accessed by different clients and different users behind these clients, then it becomes practically impossible to manage without appropriate machinery to do the management and to do the security. Why is this growth of APIs? So there are, I listed here a couple of API boosters, the motivations, the business motivations for using more APIs. So we all know about the usage of mobile applications. It is, it happens in the last 20 years. The usage of mobile applications is growing. IoT and connected devices, they access business different services. Sometimes they get information, sometimes they push information. Different B2B applications like open banking or FHIR, which is a health standard for health transmission of health information. All these are a strong business motivation for using APIs. And there are also boosters from the technology aspects, like single page applications. There is a single page that collects data from the application within a single page, and this is again API access, event-driven architectures, and of course many architectures today are based on microservices, which are a collection of which speak one with each other through APIs. The benefits of APIs from the builder, from the engineer perspective, are huge. It provides flexibility, it provides reusability. You can build API once, and then different consumers can consume this service through this API in different ways. It is easy to expand, provides excellent connectivity, and it's fairly easy to customize. However, and comes the caveat. When you look at all these API benefits from an attacker perspective, then everything that is good for the builder is awesome for the hacker, because he gets now a bigger, better, wider attack surface. When you have reusability and customizability and flexibility, then the attacker sees more edge cases, because the APIs can be used in many different ways, and probably not all these ways were tested appropriately when this API was exposed. And then the attacker will look for these edge cases and will try to find attacks on these areas. So more edge cases, more blind spots, more dusty corners, more potential vulnerabilities, more abandoned endpoint situations where APIs are being released, exposed, and then at some point they are not used anymore, but people forget about them. They just keep being there, and the attacker can predict in different ways that these APIs are still out there and available, and continue to access them. And sometimes, you put an awesome locks on your door, but the attacker can come through the window. And eventually the attacker gets more and more opportunities to attack your application when it is exposed through API. And this is not a theoretical discussion. API attacks are happening, and are happening big time. These are only a couple of examples from the recent years, and there are many more. So what we got so far? So APIs are on the rise. They are used more and more by more organizations and more widely within each of these organizations. Builders love APIs, and hackers love them as well. Next, the next couple of slides, I will dive into application security what are the threats and mitigations of web applications. So this list is was designed by OWASP in 2017. This is OWASP top 10, the 10 most significant threats on applications. So the first one, and this is not surprising at all, is injection. We are familiar with a lot of injection comes in many flavors. It can be SQL injection, it can be a remote command injection, it can be other injection. Other ones that are important and worth discussion are sensitive data exposure, which is A3, and broken access control, which is A5. And when you the discussion, the understanding about application security is pretty mature. People understand that the threats, understand the mitigation techniques. There is a lot of discussion and methodology about what are the attacks, what are the mitigation techniques, and how to use them, and when to use them, and in which manner. And if you look at, I'm sorry, just a second. Let me turn on the air condition here because it's becoming pretty hot. Okay, my apology for this short break. So if you look at the application development lifecycle, starting from concept to prototyping to development, testing, deployment, release, and then continue to the application continues to evolve with new concepts and new additions. Then the different security mechanisms of applications are appearing in different stages. So in the concept phase, there is the secure design. Make sure that try to build the new function in a way that is secure. Throughout the development and testing, not exactly, it can be either way. There are static testing tools. Look at the code, look at the different libraries that we're using, and try to find vulnerabilities within the code or within these libraries. Next, once the application is ready, you can run dynamic testing. You can run different scanners to test your application to find vulnerabilities that that are left and were not seen within the static testing. You can run also pen testing on this part. Then you do the deployment of the application and release it to the open. You expose the application to the internet. Then it is important to use runtime detection and protection. Usually you will find here a WAF, web application firewall, which will look at all the traffic to this application and try to detect the attacks that were missed, that we weren't able to detect them throughout before the deployment, and to block them. And once different attacks are being identified and different vulnerabilities are being identified, then it comes the stage of remediation. Takes take all the input, the insights that were detected by the runtime protection, and improve and fix vulnerabilities, improve them, and it goes on and on. Now, however, there is one very big elephant in the room, which is which makes this process pretty complicated, and more complicated and less trivial, which is the usage of third-party code. We all know that today, I think about more than 80% of the code of an application was not written by the organization that released this application, but is being imported from different open source libraries. And when this code comes from outside, then the entire workflow here it becomes broken, because this is not your code, so it is harder for you to design it in a secure fashion, for example. And this is also something that application developers need to handle. So the runtime protection is usually done by Web Application Firewall, WAF. WAF usually work based on rules, or sometimes called signatures, a collection which can be dozens or hundreds or thousands of security rules looking for different patterns that are known to represent different attack vectors. Try to detect these patterns within the incoming traffic. And once detected, the WAF understands that this looks like an attack and can block them. There are other security mechanisms that are used by a WAF, for example, IP reputation, collect lists of IP addresses from which attackers work and blacklist them, can work on clients, detecting bots and their behavior and all sorts of automation attempts and things like that. And there are other mechanisms. However, one domain that is pretty hard to deploy, to use within WAF, is to build traffic models, to learn the traffic, to build a model of how the traffic looks like, in order to detect anomalies whenever things that are traffic does not look like this model, to alert on attack. The reason that this mechanism is more problematic for web applications is that web applications are very dynamic, and the access that is done to them is made by the browser, by the person. And inputs that are provided by the person are not always that predictable, meaning that if you try to build a model of the traffic, when you look at the traffic for, let's say, 1 week or 3 weeks or even a couple of months, then nobody can guarantee to you that the traffic of the next user that will use this application will look similar. And then when you use traffic models, it becomes very false positive prone and pretty hard to use. Not impossible to use, but harder to use. And we will get later in the context of how to protect APIs, we get back to this idea of traffic models and anomaly detection, because when it comes to APIs, since the traffic is being generated by sort of machines, then it has more patterns, more recurring patterns, and it is more easy to learn and more easy to enforce later on. So except for the runtime protection, there is also application security testing. Again, this is, this industry of application security testing and the methodology evolved in the last 10, maybe 15, maybe even 20, maybe even more years. There are many static application security testing tools that look at the code, look for vulnerabilities, for insecure handling of user inputs, insecure functions that were written insecurely, and detect them and alert very, very early in the development life cycle. There are also many dynamic application security testing tools that are out there, are available. And many organizations, before they release an application, they hire pen testing companies or experts that will try to find manually different vulnerabilities and ways to get in so that they can fix them before they release them. This area is very mature. There are many solutions out there, and a pretty stable methodology. So let me summarize what we got so far. So application security is a pretty mature domain. Threat mitigation technologies are well understood and are widely deployed. People understand the threats, understand the mitigations, and this area of web applications is pretty mature. Next, we'll go to discuss how things look in the world of APIs. The list that you are seeing here, this is the API security top 10 threats. It was released by the OWASP organization. OWASP is the web application security group that tries to standardize, to build a common knowledge for securing applications. And not very surprisingly, this is not exactly the list of application security, meaning that OWASP understand that, and I think it is pretty accepted by everybody practically, that the threats on APIs are different than the threats on application. So for example, the injection, which was the #1 threat when it comes to web applications, it now in threat number 8, because it is still there. SQL injection is possible, or also when it comes to APIs. However, there are threats that are more significant within APIs. I will focus on some of these threats that are more important in APIs than they are in web applications. But one thing that you can look and notice already now, that both in the threats in the threat list and in the attack list, you see a lot of usage of the notion of data. Data is being stolen, data is leaking, objects are being, the threat is taking objects or exposure of data. And indeed, if you think of APIs, they're actually, think of them like a big pipe that connects the internet to your data centers, to your organization, to all the assets of your organization. Now, when it comes to web applications, the access is usually by person. So you can use rate limit mechanisms, for example. You can control what is then the amount of traffic that you allow to use for the web application. However, when it comes to APIs, then sometimes the API is being accessed by a consumer that represents many different users. And then what you will see is just a large flow of data between your API and this consumer, which is harder to understand, but is actually a collection of many different users all accessing this your API through this consumer. And it is much harder to detect and much harder to control, and it is not, it cannot be secured with the traditional mechanisms that are used by tools like web application. #1. I see now that I have some issue with my internet connection, so I apologize, but let me turn off my video. Hope that it will help keep the the connection and the slides and my audio continues. So API threat number 1 is broken object level authorization, sometimes called BOLA, which is the acronym. The attack essentially is that an authenticated user, it is important that it is an authenticated user, meaning that a user is authorized to do something within this API. So he's authorized to access certain object within the API. For example, if I have a vehicle, a car, then I can access, my car can access the information that is relevant for my car or for myself. Now, the vulnerability happens when the APIs fail to prevent the user, for example, myself, from accessing other objects. For example, information about the car or personal data of another vehicle for other users of this system. Somehow, and for different reasons, which I will not get into them in this because we don't have time to get into them. In many cases, APIs fail to prevent this situation. And in many cases, what we see is that a user can access more than what is supposed to be allowed to access. Now, one important thing about this threat, Ebola, that this is a business logic issue, meaning that if you are looking only on the syntax of the request, you will see that the authentication is okay, the user is okay, is authenticated, and everything is good, is asking for information of a certain type, the request look okay. However, something in the business logic was broken, because now he's not accessing his own data, but he's accessing data that belongs to someone else. And it is much harder to detect with tactical tools, either in runtime protection or even in the testing, before the release, in the testing of the application, because you need to understand the business logic in order to test these properly. This attack, again, as I said, attacks on APIs are not theoretical. This is an example of something that happened in T-Mobile. In this case, the user accessed the APIs, it was authenticated, and the normal protocol was that the user sends his user ID and his phone number, and he gets a collection of information about himself, like email address, device ID, and other different parameters. However, if the same user now picked a random phone number and replaced his phone number with this random phone number, and assuming that this phone number belongs to someone that is also within the framework of T-Mobile, then the API looked at the phone number and said, okay, I need to bring data based on this phone number as a key. And then he brought the data of a person that has this other phone number. And in that case, this user now got the information that is belonging to a different user. And in the same way, this user can now, and actually did, continue to send different phone numbers, can be dozen phone numbers, hundreds, thousands, millions phone numbers, and collect data about a large number of users of this vendor. And again, this is not a theoretical attack. It happened. This vulnerability was actually found, and it happens, and it is available in pretty many APIs. Let's look at another API threat, API 3, which is called excessive data exposure. Consider this situation. You have an API. Behind the API, there is a server, the database that has a lot of information about the users. There is a function, a very basic function that this API needs to provide to its clients, which is the clients think of the client as a mobile application, for example. And the mobile application wants to show to David, which is a user of this of the mobile, to show a message, "Good morning, David." In order to show this message, then the mobile application needs to know that the first name of this user is David. And theoretically, what you would expect to find here is that the first name of the user will be taken, will be accessed through this API. The client will ask for the first name, will get the first name, and will present this first name. However, when because of the flexibility and reusability design criteria of APIs, then in many cases the person that will write the implementation of this functionality within API, it will say, okay, today they want to show "Good morning, David." Tomorrow they will want to show "Good morning, David Smith." And then they will decide that they want to, I don't know, to find something about his city, which is Tel Aviv. You know what? Instead of just sending him the David, I will send him everything. Now, think of that there is a user at the end. Now, the person that writes, the developer that writes the API, it does not care whether the user at the end needs to see all this information, because he is assuming that the mobile application will show the user what he needs to be shown. It can show him David, can show David Smith, can show David Smith from Tel Aviv, can show whatever he wants, but all the information will be provided to the mobile application. Now, what this developer does not think of is that once all this information had left the API, had left the server, it is out there, meaning that all this information is out of the control of this server anymore. And if you now combine the vulnerability that I discussed earlier, that a user can access the information of another user, and this vulnerability where instead of getting only the first name, the API provides all the data record of this user, combine these two, and you get a huge data breach where one user can take all the information that belongs, that is related to all the users of this service. And this is, again, something that is less happening in APIs, because in web applications, because in web applications, the developer knows that the page that he sends to the user, this is what the user will see. So the tendency of the developer is to just provide what the user is supposed to see. When it comes to API, the developer knows that information that is not relevant will not be seen by the user, so it feels more free to send extra information in order to provide reusability to the mobile application. So the idea is the idea of API vulnerabilities that it is not very easy. I don't want to say impossible, because I almost never used the word impossible, but it is very hard to protect from these vulnerabilities if you only look at patterns, at attack patterns, and try to find them. You need to understand the different fields, the different parameters within the request, within the response, to understand the relation between them, and this is much harder to find if you only look at the syntax of which characters occur in the requests or in the responses. Now, when it comes to business logic vulnerabilities, then the good news, they are harder for attackers to find. It is much easier for attacker to detect that there is an SQL injection vulnerability or cross-site scripting vulnerability within an application. There are plenty of tools out there. He only needs to download one of them, to press play, and it's good to go. You can know exactly on which locations, on which URLs within the application you have SQL injection vulnerability. So the good news from our side is that it is harder for attackers to find business logic vulnerabilities, and it is harder to find for blind scanning attack. It is possible to do automation using tools like Postman or actually any programming language or scripting language like Python, but it is not as easy as just running SQL. The bad news is that these vulnerabilities are also harder for you to find, because all these static rules, they become much less effective. And the thing is that even more bad news is that the successful attack on the business logic, it may impact your business. It will not only attack a single user, but it can the attacker can scrap business data that is important to you and harm your business. It can scrap the data of all your users, and then this is data breach will have a significant bad impact on your organization. It can access sometimes sensitive administrator functions, which you thought you're only exposing to your administrator, but they are there, they are out there, and other users can also sometimes access them. And what we're seeing is that in practice, many of the attacks on APIs are less, of the spray and pray type. It is less someone just sitting in his couch somewhere and trying all the different IPs, doing port scanning, and trying to test for different vulnerabilities. Attacks on APIs, in more cases, are targeted, meaning that someone knows what you're doing, is interested in doing something bad within your application. For example, steal your business data to scrap prices or to get information about your users. And then he will make the investment to understand, to reverse engineer your API, and to understand what are the best way to attack them. And in that case, and this is why I put the word "the good" here in quotes, is that it is not that good, because it is good only if you believe in security by obscurity. But security by obscurity does not work. Attackers that want to attack you, they will find the vulnerabilities that are available out there, and they will try to exploit them. And if it is harder for you to find them, and if it is harder for you to protect them, then you should be really concerned about these attackers. So let me summarize what we have so far. So API threat landscape is different than web applications. Business logic attacks and targeted attacks become a significant threat vector, and the data leakage becomes a significant risk factor. And next, we will dive into what are the challenges in API security and what are the opportunities that API security provides us. So the challenges, I think we talked about most of them, but we can. I wanted to put them in a single list to make sure we are seeing them together. So dynamic application security testing becomes problematic. Just running a scanner that looks on the different URLs, which was possible in more applications, is not possible anymore. You cannot do crawling like we did in web applications. So discovery becomes a bigger problem. It is much more probable to forget 2, 3, or 200 APIs or old versions, to leave them open. It happens more when it comes to APIs. Application changes are more prominent, and there are more dynamic creatures. Client detection, detecting automation by JavaScript or things like that becomes less effective, because practically every client that accesses the API is a machine, is something that is automated. Threat landscape shifts from towards business logic vulnerabilities and attacks. Rule-based security provides insufficient coverage, and in many cases, the APIs, the usage is as a huge pipe connecting the attackers that are residing in the outside into your data systems. But before we are becoming frustrated, let's go to the other side, which is what are the opportunities that we have as defenders when it comes to API security. And the first and the most important one from my side, at least, is that the traffic to API tends to be more structured, and thus it facilitates better traffic modeling. Because access is being made by machines, it is easier to learn, it is easier to enforce and to look for anomalies, and anomaly detection becomes much more effective. API specification is usually available. It's known as a Swagger. So it is facilitates a basic discovery, basic security out of the box, if the Swagger is built well. And there is also a way to, if you use tools to analyze the Swagger, you can sometimes detect vulnerabilities before releasing the API, just by looking at the Swagger and finding different misconfigurations there. Clients tend to be more repetitive, again, related to the anomaly detection. Most of the API's functions require authentication, and then you can use rate limit mechanisms that are relying on users and not on IPs, like is usually done in web application. So most of the API traffic is associated with specific users, as I said. Running traffic analysis can support early testing and discovery. If you look at the traffic, then actually you can identify potential vulnerabilities, and then you can enrich your test suite with these potential vulnerabilities, and then you can close them and prevent them and patch them before pretty early. So I think if we combine these challenges and opportunities, I think the ideal API security strategy, I think this is true in many cases, is to try to take advantage of the security opportunities in order to address the security challenges that are imposed by APIs. Indeed, if these are the above list of challenges, then just a second. Okay, so we can build business logic security testing models from the runtime analysis, and then it provides us a better security against the business logic attacks. We can utilize the API schema docs, the Swagger, in order to identify misconfiguration issues very early within the API lifecycle, and to fully complete the shift left, to implement the shift left on security testing. We can dynamically discover a new API by looking at the traffic, and we can the application changes become more prominent, but we can detect these changes, evaluate them, and to keep to keep the traffic models within the API protection, to keep them up to date. We can utilize the user-based natures of APIs to build user-centric security. So when it comes to rate limit, to use rate limit mechanism that count the requests or the data that is being extracted, being accessed by every user, and not an IP or by anonymize the users. We can also understand the data that is being accessed by every user, and use rate limit mechanisms on this on the data itself for the user. We can utilize business logic models in order to understand the API business models and to identify business models risks, and also to detect business logic attacks. All these are possible if you use the appropriate security mechanisms. And we can also, in many cases, we can do user granularity threat detection and to detect the data that is being used, flowing through this API. So I'll start to summarize. I want to leave a couple of minutes for questions. So API security is a new domain. I think there is no argument about that. It took a couple of years to understand that this is a new domain that is not identical security-wise to web applications, but I think now it is very well understood. In order to protect APIs, you need to build security along the API lifecycle to analyze the schema, to feed the information about the schema and schema insights in order to provide better runtime protection, to use the runtime protection in order to identify potential vulnerabilities, and then to feed the security testing mechanisms, and all these components to have them talk with each other and improve each other and to leverage each other. You need to make sure to cover business logic threats with identifying the relation between the different fields, identify the data that is flowing through the API, the relation between the data and the users. This is the way to protect the APIs. And this is a very schematic diagram of what we do at Envision. We are providing security technology to protect APIs along the entire life cycle, in the schema level, the testing level, and the runtime level. And these components talk with each other in order to improve, to leverage each other with the information and the knowledge that is generated by the other. So let me summarize. So APIs are very different from web applications. It is far beyond the syntactic difference of JSON versus HTML. The different syntax of API, the different usage, induces a very different threat model with much more business logic vulnerabilities. Using the incorrect security methodology and security machinery may result, you run testing tools, you will see that everything looks okay, but this would be a false confidence. You think you're okay, but still you have vulnerabilities, business logical vulnerabilities that you just didn't find. And you should be very careful about this false confidence. And the tailor-specific API security solution is not a luxury anymore. This is a necessity for anyone, any organization that uses more than a double-digit number of APIs. Thank you very much, and I think we have a couple of minutes for. I will be happy to answer questions if you have.
Okay, thank you very much, Itsik, for your presentation. So we come to the question and answer session. So there is a question from Tony Adi Sebastian. So are there any clear and easy guidelines for integrating security aspect into test-driven development process in order to prevent vulnerability propagate further into later stage of development and deploy process.
Okay, thank you for the question. It's very good question. There are several ways to do that. One way is to look at the schema. When you usually when you build API, then part of the development lifecycle is the generation of a schema for this API. And then there are security tools like our security tools that look at the schema and can give you information and give you many security insights about different misconfigurations in your APIs that you need to sometimes to just go and fix them because there are definitely vulnerabilities. And sometimes you can just give you hints about what are the things you need to test. So this is one half of the answer. The other half of the answer, if I go back to this arrow here, so when you are using the runtime API security, then the runtime API security actually builds knowledge about the business model of the application and the API. And now this knowledge, you can translate it into a list of potential vulnerabilities, a list of potential attack vectors on your APIs, and then you can go and run these tests as part of the development lifecycle. So here, it is correct that when you run this, if you already released APIs, then the vulnerabilities are out there, but you can learn about them and learn how to test them, and then you can fix them quickly. Another approach, which some of our customers are using, is to do the runtime analysis on the staging environment, and then on the staging environment, the tool learn the traffic, learn the business logic, and then it can generate the security insights about potential vulnerabilities and test vectors and attack vectors before the API is actually deployed and exposed out there.
Oke, thank you Itsik. Semoga pertanyaan Pak Tony Adi terjawab ya untuk pertanyaannya. Oke, berhubung dengan because of the time, we almost come to 8 p.m. So we continue to the next session by Mr. Didiet. But before that, we should thank you, Mr. Itsik, for your presentation. Oke, untuk sesi berikutnya, kita persilakan Pak Didiet A. Pambudiono yang akan membawakan topiknya kali ini, yaitu Secure Your Application with Google Cloud Apparmor ya. Ya, kalau begitu langsung saja kita persilakan Pak Didiet Agus Pambudiono untuk menyajikan topiknya. Silakan Pak. Terima kasih.
Baik, terima kasih atas kesempatannya Mas Wisnu untuk kesempatan kali ini. Ini kita akan membahas tentang udah kelihatan ya presentasinya ya.
Ya, sudah Pak.
Sudah ya, bentar. Nah, yang kita bahas untuk kesempatan malam ini adalah untuk judulnya Secure Your Application with Google Cloud Apparmor. Yang kemarin di posternya, maaf itu kesalahan saya ya, ini sebenarnya bukan Apparmor tapi Apparmor. Kalau Apparmor itu yang ini di level kernel, tapi ini kita akan levelnya di luar dari sistem. Ya, perkenalkan tentang saya ini, saya adalah seorang DevOps Engineer yang saat ini bekerja di PT DevOps Indonesia yang lokasinya di Bandung. Nah, untuk komunitas saya termasuk di beberapa komunitas antara lain Open Source Project sama komunitas Open Source yang Indonesia itu ada kelas ini kelompok Linux Arek Surabaya, dan juga sebagai member dari Kubernetes Indonesia, dan sebagai kalau diterusin jadi panjang ya. Nah, seorang cloud enthusiast yang bisa dihubungi di email antara lain 1 dari 3 ini ya, didit@kids.id itu untuk working atau untuk pekerjaan. Kalau untuk komunitas bisa di pambudiono@opensource.org atau pambudiono.os@gmail.com. Agenda malam ini itu adalah pengenalan, ada beberapa bagian, yaitu ada pengenalan, kemudian network security overview, yang ketiga itu Cloud Apparmor, 4 itu WAF and DDoS, kemudian yang terakhir itu protecting your application. Ini berhubung nanti demonya saya sebenarnya karena tadi ada kejadian hari ini anak saya demam, jadi mungkin untuk demonya belum saya persiapkan sangat ini ya, mohon maaf ya.
Iya Pak, tidak apa-apa.
Nah, introduction kenapa why WAF atau Web Application Firewall. Nah, kenapa kita harus pakai WAF ini ya? Nah, banyak macam atau banyak alasannya ya. Pertama itu untuk melindungi bisnis yang saat ini sedang berjalan. Nah, banyak sekali kasus yang ketika sebuah website tanpa adanya Web Application Firewall itu terjadi beberapa kejadian. Ya, yang paling umum ini juga fungsinya untuk melindungi serangan-serangan yang paling umum. Misalkan DDoS, Distributed Denial of Service. Jadi gimana caranya sebuah website atau sebuah server itu tidak dapat diakses sama sekali. Nah, jadi ini perlu untuk melindungi bisnis kita dari serangan-serangan yang seperti ini. Yang ketiga, ini mempermudah untuk perawatan ya, atau maintenance. Nah, bayangkan kalau tanpa Web Application Firewall, ketika ada serangan, ketika ada penyusupan, itu maka kita sebagai engineer, terutama yang urusan sama infra sama networking, itu pasti akan repot. Nah, ini saya alami sendiri beberapa tahun yang lalu ketika sebuah server itu, kebetulan server yang saya juga maintain, ada serangan karena port-port yang sensitif itu dipublish. Nah, port-port yang sensitif itu apa aja yang dipublish gitu, misalkan port database, mungkin MySQL atau PostgreSQL atau bahkan MongoDB. Nah, sering juga ini kejadian ya, untuk terutama yang menggunakan MongoDB dan MySQL itu kerentanannya sangat tinggi. Udah beberapa kali mungkin ya, bukan hanya saya yang mengalami, saya pernah mengalami juga, data di database server itu tiba-tiba di-grab sama orang yang tidak bertanggung jawab dan meminta tebusan. Ya, kebetulan ya untungnya bukan data-data yang bukan di server production ya. Nah, kenapa juga kita butuh WAF ini? Ini sangat sesuai dengan security tools yang lain. Mungkin kalau di Google Cloud Platform ini ada biasanya WAF ini jadi satu sama yang namanya load balancer. GCLB Google Cloud Load Balancer. Ya, setelah itu, nah, kita bahas tentang Network Security Overview. Aslinya ini Defense in-depth ini Network Security in the Cloud. Nah, kebanyakan orang menganggap kalau data sudah di cloud itu sudah pasti aman. Kebanyakan orang awam ya, bukan orang awam aja, ada beberapa engineer atau developer yang menganggap seperti itu. Oh, sudah di cloud kok, ini pasti sudah aman. Padahal sebenarnya tidak. Ya, sisi keamanan itu siapa yang harus menentukan? Yaitu usernya sendiri, bukan dari provider. Ya, beberapa kejadian seperti ini, loh, ini cloud ini udah pasti aman. Port database, bukan port database saja ya. Dulu itu pernah ada yang open all port itu dipublish ke internet. Jadi mulai port HTTP, port HTTPS, bahkan port database juga dipublish. Kejadiannya efeknya apa? Ternyata ada yang iseng berhasil masuk ke database itu. Nah, ini sebuah kesalahan yang sangat fatal ya. Untuk defense in depth ini ada beberapa tingkatan. Yang pertama yang paling bawah sendiri yaitu microsegment access to your application and service. Kalau di GCP itu ada beberapa yang bisa di-set, antara lain di IAM atau Identity and Access Management. Nah, ini bisa di-set di API based access. Jadi aksesnya hanya boleh dari API atau Istio security based. Nah, ini yang biasa digunakan di Kubernetes itu ada Istio ya. Jadi base-nya itu antara di ID di HTTP atau HTTPS. Firewall per service account. Nah, ini untuk apps yang base-nya pada VM atau virtual machine. Nah, di GKE Network Policies ini hanya berhubungan pada cluster di GKE. Jadi kalau dari saya secara pribadi, kalau ada GKE Network Policies, maka hanya di lingkup satu cluster itu aja yang boleh berkomunikasi secara bebas. Di luar cluster itu harus ada beberapa rule yang harus dilakukan. Kemudian ada Secure VPC for Private Deployment. Nah, Secure VPC ini kita gunakan untuk VPC atau Virtual Private Connection atau Cloud ya, saya juga lupa ya. Ini ada beberapa segmen. Di sini ada Service Control, Level Firewall, Outbound NAT Proxy. Nah, Outbound NAT Proxy ini biasanya kalau misalkan satu server ini tidak boleh di publish ke internet atau bisa di internet tapi ada beberapa batasan bisa pakai outbound ini. Nah, VPN and interconnect ini sebagai akses untuk ke VM atau ke service di GCP. Mungkin beberapa tahun 2019 ketika DevOps Meetup di Bandung itu saya membawakan gimana caranya biar di VM itu atau Google Cloud Engine itu intinya untuk aksesnya itu tidak boleh sembarangan. Nah, waktu itu saya membawakan tentang Bastion. Bastion ini fungsinya apa? Ini hanya ada satu server yang sudah di harden. Mungkin dia hanya membawa satu service saja atau SSH atau VPN atau dua-duanya, tapi gimana caranya untuk di hardening. Jadi untuk akses ke server yang lain, misalkan ada server web untuk production, untuk manajemennya itu harus lewat VPN. Tidak boleh lewat langsung ke dalam VM itu dari IP public. No ya. Kemudian untuk private Google Access, jadi untuk Google Cloud Storage, BigQuery, SQL, Redis ini usahakan hanya boleh diakses dari satu titik dan hanya boleh private access saja. Nah, contohnya tadi hubungannya sama VPN dan interconnect. Atau di private GKE, Google Kubernetes Engine dan VMs. Nah, ini sebenarnya ini yang disarankan ya, bahkan di wajib ini sebenarnya tidak boleh ada IP public. Ya, kalau untuk production itu sebisa mungkin tanpa ada IP public. Kalau untuk development mungkin masih dibutuhkan ya IP public ya, biar kita tahu juga ini vulnerable-nya sampai di mana gini. Yang paling depan sendiri, nah ini biasanya app itu kan head to head ke internet. Nah, ini ada beberapa teknik ya, antara lain global load balancing, TLS everywhere, ini yang nanti kita bahas itu adalah Cloud Apparmor. Jadi application based control. Jadi kontrolnya itu based on application. Itu di Cloud Apparmor. Kemudian yang IAP ini identity based controlnya ini. Jadi yang paling dasar sendiri. Selanjutnya kita ke ini berikutnya. Nah, ini salah satu contoh yang gimana security itu harusnya itu adalah secure every path. Untuk dari yang ini head to head ke internet itu bisa menggunakan Cloud Apparmor atau IAP. Dari VPC network itu di dalamnya adalah web server project dan database project. Kemudian ada lagi yang GCS bucket. GCS itu Google Cloud Storage. Bucket itu semacam wadah ya. Jadi kayak folder yang ada di Google Cloud Storage. Nah, komunikasinya gimana? Kalau di garis hijau itu yang warna hijau, itu menggunakan Cloud Apparmor karena head to head dengan internet. Sedangkan untuk yang garis merah VPC network itu kita bagi dari tentukan dari VPC firewall. Antara lain mana database project sama web server project. Nah, komunikasinya hanya boleh dari private VPC. Tidak boleh dari public VPC atau IP public, itu nggak boleh. Jadi web server ini sebenarnya kalau bisa tanpa IP public. Nah, ini ada di sini, ada interconnect yang untuk manage di Google Cloud Storage bucket. Itu bisa pakai interconnect. Interconnect itu bisa juga ke internet. Tapi biasanya kalau GCS bucket ini, hubungannya interconnect itu cuma sampai di VPC antar VPC network ini sampai GCS bucket. Baru on-premise ini misalkan ada router di sini, ini ada interconnect untuk GCS bucket. Nah, yang sudah saya terapkan itu antara di sini ada VPC interconnect di salah satu titik, kebetulan di kantor saya, untuk akses di salah satu project di Google Cloud itu lewat interconnect atau pakai VPN ya. VPN. Jadi semua akses itu hanya boleh dari kantor. Nah, kalau sekarang WFH atau working from home, kalau dulu working from office nggak ada masalah. Semua akses dari kantor boleh ke project. Nah, sekarang posisinya WFH, working from home, atau WFE, working from everywhere. Gimana caranya untuk akses di project ini? Terkadang beberapa teman atau beberapa engineer di luar itu melakukan hal yang membatasi akses di sini. Misalkan pod yang boleh dibuka cuman pod SSH ini ya. Pod database itu hanya boleh diakses dari web server ini. Nah, kalau dari saya secara pribadi tidak menyarankan. Jadi di lingkungan on-premise ini kita siapkan juga sebuah VPN server. Jadi nanti user itu kalau mau manage yang di dalam ini dari internet itu masuk ke sini dulu, baru ke project. Nah, ini yang sempat jadi perdebatan dulu di kantor awal WFH, kenapa nggak dibuka gini, kenapa nggak gini. Ya akhirnya yang ngomong terserang ya kita implementasi high security ya, atau security tingkat tinggi ya. Jadi cuman hanya ada satu titik yang bisa digunakan untuk akses Google Cloud-nya. Misalkan kita VPN servernya itu ada dua, satu PPTP, satu OpenVPN. Karena provider di kita sendiri juga terkadang ada yang PPTP di allow, terkadang ada yang OpenVPN di allow ya, tergantung dari provider internet di Indonesia ya. Nah, ada ini beberapa istilah ya. Kalau ada denial of service attack ini ada 3 jenis. Yang pertama, infrastructure DDoS attack. Nah, ini protokol yang serangan itu yang digunakan volumetric atau protokol. Jadi gimana caranya bandwidth ini tersaturasi dan menghambat dari aplikasi kita untuk diakses dari luar. Contohnya menggunakan apa? TCP SYN flood atau DNS amplification attack atau IP fragmentation dan lain sebagainya. Kemudian ada application aware attack. Jadi yang ini kalau application aware attack ini yang dieksploitasi adalah kelemahan dari aplikasi ini. Nah, contohnya misalkan dulu sempat nemu ya di salah satu website pemerintahan atau BUMN, saya lupa. Itu environment variable-nya itu terbuka, jadi bisa diakses dari luar. Environment variable misalkan disimpan di file yang namanya .env. Padahal di situ ada kredensial yang istilahnya tidak boleh orang luar itu tahu. Misalkan database ini usernya apa, passwordnya apa, IP-nya berapa gitu. Nah, kebetulan waktu itu env-nya itu database-nya sama username passwordnya itu dipublish secara terang-terangan. Jadinya bisa kita lakukan untuk eksploitasi ke dalam website tersebut. Ada lagi yang cross-site scripting ini atau singkatannya XSS. Nah, ini sangat bahaya sekali, tapi ini sudah bisa di setup untuk di disable atau di deny. Kalau kasus yang paling terkenal itu adalah SQL injection tahun 2004. Saya masih ingat itu, yang pelakunya adalah kebetulan juga saya kenal, Mas Dani, yang melakukan defacing atau mengganti database nama-nama partai-partai di situs KPU. Ada juga multi-factor attacks. Maaf tulisannya salah. Jadi di antara dua ini bisa dipakai untuk maaf ini ya, menggunakan attack vector itu ya, bisa infrastruktur sama application secara barengan. Atau untuk infrastrukturnya bisa pakai untuk beberapa titik ya, dari beberapa titik. Itu sering yang kita temuin seperti itu. Nah, Cloud Apparmor di Google Cloud ini fungsinya apa? Melindungi aplikasi kita atau website kita dari serangan denial of service dan web attack. Sering dulu sebelum di Git itu seringkali ada brute force dari ini website kebetulan yang saya pegang itu perusahaan yang sebelum saya di Git ini ada beberapa website itu serangannya adalah denial of service sama web attack. Web attack-nya itu macam-macam. Dia scanning apa aja yang bisa di scan di website itu. Ya, sebenarnya kalau yang sudah biasa itu gampang ya, tinggal di deny aja IP-IP yang melakukan serangan. Nah, itu kalau untuk 1 atau 2 server mungkin dari tim infranya masih bisa ngatasin. Nah, kalau misalkan ada beberapa server misalkan lebih dari 10 dan ke 10-nya itu diserang bareng-bareng mungkin akan merepotkan ya. Jadi kenapa kita perlu yang namanya Cloud Apparmor ini ya. Nah, untuk keuntungannya ini proteksi DDoS dan WAF-nya ini di dalam Google Scale. Nah, untuk mitigasi dan deteksi ini bisa dilakukan dari workload cloud balancing. Untuk protection-nya itu beradaptasi dari secara ini machine learning based mekanisme ya. Jadi itu detect dan block layer 7 itu layernya aplikasi ya. Dan termasuk dalam OWASP Top 10 Risk dan ini yang membantu untuk melindungi workload baik itu on-premise atau di dalam cloud. Nah, bisa juga untuk stop fraud-nya itu ya di Edge itu menggunakan integrasi dengan reCAPTCHA ya. reCAPTCHA yang versi enterprise. Cloud Apparmor selanjutnya nah, misalkan ini seperti ini. Ada user yang lewat sebuah ISP network atau internet. Ini masuk ke dalam Google Ads POP, Point of Present. Kemudian dari sini, ini ada load balancing yang ada di Ads. Ads itu kayak apa ya, istilahnya seolah-olah misalkan server kita di Amerika, tapi kita langganan Google Ads. Jadi Ads itu seolah-olah kita aksesnya itu ke Jakarta. Ads ini fungsinya tidak menyimpan data, hanya menyimpan sebuah data sementara. Jadi tetap akan ngambil data dari server yang sebenarnya. Kalau misalkan ada server di Amerika atau di Eropa, Ads itu akan mengambil dari Amerika dan Eropa. Jadi kalau misalkan yang akses orang Indonesia, yang Ads terdekat, misalkan Singapura, itu yang akan menyimpan data sementaranya. Atau kalau di Asia, itu misalkan dari Tokyo atau dari Hong Kong, ya Ads yang ada di Hong Kong atau Tokyo yang akan bekerja. Nah, di sini baru yang ini akan diproses di Google Backbone, kemudian yang akan disalurkan ke Google Data Center. Nah, seperti itu cara kerjanya. Nah, Cloud Apparmor ini juga berfungsi sebagai pertahanan terhadap layer 3 atau layer 4 protokol DDoS attack. Jadi distributed denial of service. Ketika ada request HTTPS, ini maka akan dilanjutkan ke load balancing atau HTTPS load balancing, Google Cloud load balancing, dan dengan adanya Cloud Apparmor, ini kita bisa tentukan ya, IP mana yang di-allow, IP mana yang di-deny, atau lewat geolocation dan Web Application Firewall atau Custom Rules dari level 3 sampai level 7. Nah, ini akan ditentukan ya. Kalau itu ditolak, ya dari sini tidak akan dilanjutkan ke bawah. Kalau ternyata di geolocation itu tadi, itu bisa dipecah-pecah menjadi beberapa data center. Contohnya di sini US Central, US West, sama Asia. Contohnya seperti itu. Terakhir use case-nya ini misalkan untuk use case-nya antara lain ya, kalau user dengan spesifik IP address ini bisa di list per allowance. Jadi misalkan kita punya kliennya itu internetnya dedicated, punya IP public sendiri. Nah, kita bisa allow IP public tersebut, contohnya di IP public kantor saya atau IP public klien di Jakarta. Kalau kantor di Bandung, di Jakarta itu bisa di whitelist. Atau yang kedua itu bisa denial ini ya, specific IP address. Misalkan ada IP, terutama IP dari salah satu negara baik itu di Asia atau di Eropa, itu mesti seringkali melakukan keisengan, misalkan melakukan distributed denial of service attack gitu ya, serangan DDoS. Nah, kalau di sini ini bisa dibalik, kalau tadi di allow, yang ini di deny. Nah, saya umumnya melakukan begitu kalau ada IP yang dari negara tertentu, itu yang kalau iseng sih ya satu negara itu yang saya blok gitu. Karena kita sendiri bisa tahu list-list IP apa aja yang lokasinya di salah satu negara gitu ya. Itu bisa pakai geolocation gitu. Nah, dengan rule yang ada di Web Application Firewall itu, ini kita bisa melindungi aplikasi ya dari development dari layer ya, serangan per layer dari layer 3 ke layer 7 tadi ya. Nah, dari sini kita juga bisa melakukan monitoring untuk layer ke-7 atau layer aplikasi ya. Di Cloud Apparmor sendiri, itu bisa ada isu seperti termasuk local file atau remote file ya, atau SQL injection, cross-site scripting, dan remote code execution. Misalkan ada code atau kode yang dieksekusi dari remote untuk melakukan brute force atau apa itu ya, ini bisa di-handle juga dari Cloud Apparmor. Nah, mungkin karena ini ya, jadi sebenarnya nggak banyak juga yang bisa saya sampaikan. Apakah demo ini mungkin untuk eksekusinya bisa dari, sebentar saya stop dulu untuk share-nya. Mungkin ada pertanyaan ya.
Oke, terima kasih Pak Didiet atas sharing-nya. Mungkin untuk rekan-rekan kalau ada pertanyaan ya, karena kita masih ada waktu kurang lebih 30 menit sampai closing.
Ya, kita lanjutkan aja ke demo dulu ya, sambil
Ya,
ini ya.
silakan Pak, demo dulu Pak.
Nah, demonya sendiri. Nah, demonya sendiri ini misalkan di sini ini saya punya project di development. Kalau Cloud Apparmor-nya di sendiri itu di set di sini security. Ada network security ya, ini di network security ini ada 3 SSL Policy, Cloud IDS atau Cloud Apparmor. Kita bisa pilih Cloud Apparmor-nya. Nah, kemudian bisa create policy-nya. misalkan namanya policy type-nya bisa apa? Back-end security policy atau edge security policy. Kita pilih back-end aja biasanya soalnya yang langsung ke server. Sementara karena yang akses dari server kita itu kebanyakan dari lokal Indo, maka untuk sementara kita tidak ada policy untuk edge, Google Edge ya. Untuk default-nya bisa pilih allow atau deny. Misal kalau deny itu ada forbidden, not found, atau bad gateway. Ini bisa kita akalin ya. Kalau misalkan bad gateway seolah-olah service kita yang kita jalankan itu error. Padahal ya enggak. Gitu. Kalau not found ya sama, forbidden ya sama. Oh ini nggak boleh akses ke sini. Kalau itu sudah umum ya. Atau not found, seolah-olah service itu tidak ada gitu. Misalkan API bla 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 .domain/API, kita bisa set ke deny statusnya not found atau forbidden atau bad gateway. Nah, kemudian selanjutnya add more rule, add rule-nya ini contohnya misalkan hanya untuk akses dari HQ. Nah, bisa dari basic mode ya atau pilih aja basic mode. Misalkan di sini ini IP router yang ada di HQ ya. Nah, ini access-nya allow. Priority-nya misalkan 0. 0 ini highest. Ini done. Misalkan rule-nya hanya boleh dari sini. Next step-nya nah ini harus ada di load balancer. Kebetulan saya tidak ada ya, tidak punya load balancer. Mungkin kita coba bisa next. Oh ternyata saya nggak punya ini ya, nggak punya untuk manage protection plus ya. Oke, kira-kira caranya seperti itu. Baru kita group create policy-nya. Nah, contohnya seperti ini. Atau kalau adaptive protection, ini bisa ke configure backend service. Targetnya ini adalah load balancing, cloud DNS, CDN, NAT, atau traffic director, service directory, cloud domain, dan lain-lain. Nah, kita untuk ini mungkin masih harus create load balancer dulu ya. Itu caranya untuk ininya, contoh untuk setup policy dan ini ya. Kebetulan kita tidak butuh load balancer karena yang ada di sini itu service-nya adalah service development ya. Jadi tidak perlu load balancer. Kebetulan yang untuk production-nya kita di classified di client ya. Jadi kita tidak bisa share, mohon maaf ya. Mungkin itu dari saya. Ya, untuk itu saya kembalikan ke Mas Wisnu sebagai moderator.
Ya, terima kasih Pak Didiet atas sharing session-nya dan juga demonya ya. Untuk pertanyaan, apakah ada pertanyaan dari rekan-rekan sekalian?
Silakan mungkin ya kalau mumpung masih ada kesempatan ya, Mas Sistem bolehlah kalau tidak lewat chat atau kesulitan chat itu bisa langsung open mic ya. Gimana kalau gitu?
Ya, mungkin bisa ya. Kita bisa open mic juga langsung. Kalau misalkan itu nanti silakan raise hand aja, gunakan fitur raise hand. Nanti mungkin kita bisa untuk unmute dari peserta. Ya, sekaligus menunggu untuk pertanyaan dari audiens. Mungkin ini ya, kita juga nanti ada rencana di tahun depan untuk ada DevOps Day Jakarta. Jadi mungkin nanti rekan-rekan sekalian bisa stay tune terus untuk di sosmed kita, supaya nanti untuk mendapatkan informasi selengkapnya. Oke, sebentar. Ini sepertinya sudah ada pertanyaan ya. Mungkin apa mau langsung berbicara langsung atau dibacakan saja, Pak Didiet?
Ini ada pertanyaan ya, ini apa Cloud Apparmor ini sama?
Mungkin langsung ini aja ya.
Iya.
Oke,
Sama
apakah
atau beda
Cloud Apparmor
dengan
ini sama atau beda dengan Flare anti DDoS?
DOS?
Ya, silakan Pak.
Seingat saya juga pengguna Cloudflare ya, tapi kalau Cloudflare itu rule-nya simple ya, tidak spesifik di Google Cloud Apparmor ini. Sebenarnya fungsinya sama ya, anti DDoS sistem ya, tapi ya sepengetahuan saya memang tidak spesifik di Google Cloud Apparmor.
Tambahan pertanyaan Pak, boleh?
Ya silakan.
Kalau di Cloudflare kan biasanya kadang muncul tampilan tuh ya, ada kayak landing page-nya gitu, checking your IP gitu kan ya. Kalau
Ya.
di Cloud Apparmor itu user ngerasain ada proteksi nggak Pak? Atau enggak sama sekali? Kasih.
Selama ini yang saya pakai itu tidak ada user itu seperti tidak ada efek kalau harus ada landing page itu kayak gitu enggak. Misalkan di salah satu project itu klien pakai Cloud Apparmor, ya sudah ketika akses websitenya klien ya itu langsung kebuka, itu enggak ada yang checking your website di Cloudflare, itu enggak ada. Seperti itu sih kalau yang saya rasakan di Cloud Apparmor itu. Soalnya di Cloudflare misalkan ada misalkan dari satu IP yang mencurigakan, biasanya keluar itu kayak captcha ya, atau untuk verification ya. Seingat saya sih seperti itu kalau di Cloudflare.
Oke, apakah sudah jelas Pak Arief? Oke, terima kasih. Mungkin ada pertanyaan lagi sebelum kita akhir acara untuk photo session. Oke, mungkin sekaligus menunggu pertanyaan, boleh rekan-rekan sekalian mengisi polling kita ya dari DevOps Indonesia. Oke, saya munculkan terlebih dahulu. Nah, mungkin rekan-rekan sekalian bisa sambil untuk menunggu pertanyaan berikutnya, bisa sambil mengisi untuk polling kita. Silakan. Oke, mungkin Pak Didik juga bisa sekaligus menampilkan untuk yang ini ya Pak, untuk yang covernya tadi, mungkin untuk yang introduction. Jadi mungkin kalau misalkan ada pertanyaan-pertanyaan yang mau ditanyakan juga secara pribadi, bisa langsung ditanyakan ke Pak Didik langsung ya.
Ya, untuk pertanyaan Nah ini ya, kalau misalkan ada pertanyaan tentang ini bisa di salah satu di email ini.
Nah itu ya, bisa langsung ke email, langsung ke pakdidiet@kids.id, ada juga dengan atau Pambudiono at opensius ya .org dan pambudiono.os@gmail.com. Jadi nanti rekan-rekan sekalian, misalkan pertanyaannya, waduh, nggak kepikiran nih di saat ini gitu kan, tapi kepikirannya setelah baca materinya lagi, mungkin baru kepikiran. Nah, itu nanti mungkin bisa langsung ditanyakan ke kontak beliau. Itu mungkin bisa langsung di screenshot, di foto terlebih dahulu, atau nanti mungkin bisa di take notes. Oke, sepertinya belum ada pertanyaan. Mungkin kita bisa langsung masuk ke sesi foto bersama ya, Pak Didit ya, dan Mbak Mia. Oke, mungkin untuk fotonya bisa kita minta tolong untuk rekan-rekan sekalian menyalakan videonya agar kita dapat bisa sesi foto bersama.
Loh, ini Rama kenapa kok gini? Tadi dia. Ini Rama TV kok gini?
Wah, ini Mas Agus Priyadi lagi perjalanan nih.
Iya nih, ada beberapa dari peserta kita yang memang sedang dalam perjalanan ya. Jadi terima kasih banget sudah menyempatkan waktunya untuk ikut di DevOps Indonesia. Oke, mungkin saya take foto dulu. Mbak Mia, apakah sudah bisa difoto?
Sudah siap ya? Saya hitung 1, 2, 3. Oke, sudah.
Oke, terima kasih untuk sharing session-nya kali ini, Pak Didit dan Itsik ya. Pak Reno mungkin bisa disampaikan ya salamnya tadi karena Pak Itsiknya sudah ini ya, sudah lekas untuk meeting berikutnya. Oke, terima kasih dari Vision dan juga Gates Indonesia atas sharing session-nya kita malam kali ini. Saya ucapkan terima kasih banyak juga kepada para peserta yang sudah turut hadir untuk meetup kita DevOps Indonesia di malam hari ini. Oke, stay tune terus untuk di meetup-meetup kita yang mendatang, dan nanti juga ada DevOps di Jakarta, jadi nanti mungkin ditunggu aja ya kabarnya di medsos kita. Terima kasih, selamat malam.
Selamat malam.